Hi, welcome to IT and Automation. Last week, we looked into one of the scheduling decision and we covered what disruption was it. Today, I wanted to cover another evaluation factor, which is key on making those scheduling decision in Kubernetes. And the topic is topology constraints. So when do you need topology constraints? You have a deployment in Kubernetes, and this deployment may have a bunch of replicas, right? Okay, so you have a deployment and then you have bunch of replicas in that deployment, right? You may have 6 replicas for our deployment, and then let's consider you have, as a Kubernetes operator, you want even distribution here, and Kubernetes attempts to do that, but there is no guarantee that one of these pod will end up in one of the worker node. As an application owner, you would want that kind of distribution. So that's the problem scenario which we are going to cover in today's topic. As a owner of the application, you may have a deployment which has 6 replicas, as we see in this image, and you want those 6 replicas to be placed equally in 6 of your nodes. By default, Kubernetes distributes it quite nicely, but then you cannot get the guarantee of placing it in a 3 availability zone. See, this is a group of AZ1. This is a group of AZ2. And this is a group of AZ3. Right? You will not get the guarantee of this 6 evenly getting distributed. That's where the topology spread constraints comes in Kubernetes. So let's recap. Topology spread constraints in Kubernetes is a feature that allows you to control the distribution of pod across the different topology domains. It could be based on, say, it was a multi-region. It could be multi-region, multi-zone, or multi-node. Any of those breakdown is possible with topology spread constraints. And that is to ensure even distribution. So balanced scheduling and high availability, where you can avoid overloading of any single domain and enhance that fault tolerance. Whichever layer you have that fault tolerance on, AZ layer or regional layer or node layer, topology spread constraints will help you. It may be easier if we look into our deployment and we talk about it and say deployment for topology constraints. This is a sample of topology spread constraints in a deployment. So if we look into the key concepts of topology spread constraints, we will be looking into topology key here, max skews when unsatisfiable, and the label selectors. In this particular example, we have a deployment which has 6 replicas, which has some topology spread constraints. That's exactly what we looked into in here. 6 pods, 3 AGs, and how do we evenly distribute it there? Before that, let's try to understand each of these spec. Topology key. This particular attribute specifies the key used to denote the topology domain. You can denote a domain either with likes of topology kubernetes.io/zone. In this example, we're using the zone. It could have been likes of a region. It could have been likes of nodes as well. Right? And I will try to provide all of these materials in our GitHub repository. And next one is max skew, right? Max skew defines the maximum allowable difference in the number of pods between the most and least loaded topology domain. In this example, total pod we have 6, total zones we have is 3, and Total worker nodes we have is 6. And as we saw in deployment, we have a max skew of 1. What could be the possible outcome? Possible outcome in general will be 2, 2, and 2. Kubernetes aims to maintain that balanced distribution across the zone. However, with a max skew 1, in a worst case scenario, you could end up with 1, 2, and 3. That is not impossible, but generally Kubernetes will try to minimize the skew and achieve the most balanced distribution. And you will see most of the time 2, 2, and 2. And another important key or attribute here is when unsatisfiable. So what does that mean? So when unsatisfiable is a parameter that defines the action to take when the constraints cannot be met. Right? Say the constraints was not met for any reason, scheduler will not schedule the pod if constraints is violated. With the do not schedule, the scheduler will not schedule the pod. If you use schedule anyway, which is another option, the scheduler will place the pod even if the result in this queue that violates the constraints. It's something like try to do it. If not, then okay, I'm fine with scheduling it elsewhere. That sort of thing. And the fourth one is level selector, as we see in this code in here. Level selector here match label saying the pod has to be this. So this is used to identify the set of pods to which constraints applies. It's exactly the same as in PDB where selected something and said, I need at least this amount of pods to be available. So we look into this example, right? We went through this example. We talked about max skew. We talked about each of those attributes in there. So now, how does it work? From a pod distribution point of view, the scheduler attempts to distribute the specific number of replicas across the available zone, as we looked into the diagram, as evenly as possible, right? There is a chances, so we want to say it as evenly as possible. And again, talking about the same example from here, if there is a 3 zones, for instance, the scheduler will try to place 2 pods in each zone. If we were talking about what we are looking at, this deployment sample or this number of replicas, 6 replicas, 3 zones, it will place 2 pods in it. Max skew enforcement will ensure the distribution remains balanced. If one zone already has 2 and the other has 1, the scheduler will not place the 3rd pod to the first one unless the second one gets its 2nd pod. Handling violations, which is when unsatisfiable and do not schedule, that we discussed before. The scheduler will hold off scheduling depending upon what value you're using there, and that ensures if you will end up in the result of imbalance or not. So what exactly is the benefit of using topology spread constraints? Let me recap that here again. High availability. By spreading the pod across multiple topology domains, you essentially made your application more available. If the single domain fails, if the single AZ fails, your application will have a copy of replica in other availability zone. Load balancing. Distributing pod evenly across the nodes, zone, or region, whatever the domain you used in your key in here, it will be balanced accordingly. Resource utilization, effective spreading, right? It will all of your node you will be effectively used, not packing the pods into the one specific node. And if we have to talk about use case, multi-zone, multi-region deployment, critical workloads, and load balancing, enhancing the overall performance and reliability of the system by balancing the workload across the node here. And in the end, I wanted to talk about the limitations as well. Is there any limitations? Is there any consideration? In the real world, this is a complex management, right? Configuring topology spread constraints can add a complexity in your deployment configuration, depending on how you're managing it. One could see it as a single line configuration of multi-line configuration change or operational overhead. If the constraints are too strict, example, max skew is too low, it might result in a pod not being scheduled. Right? You may end up pod not being able to schedule because of your max skew, which means again the negative impact. The pods are actually not scheduled. Cluster state awareness. The scheduler's decisions are based on current state of the cluster, which can change and leading to the potential rebalancing needs. With the architectural decisions, that these can be a benefit, but also if there are changes on region or those domains that we have used, it can have a negative impact. So in summary, if I have to close it down, I would say topology spread constraints in Kubernetes provides a really powerful mechanism to control the distribution, pretty much like a telephone control systems where you have this switchboard and saying where to go. Control of the distribution, as I said, enhancing the fault tolerance, availability, resource utilization are to name few. And properly configuring these constraints can achieve a well-balanced and resilient deployment architecture based on the use case, but this is definitely a factor that should be taken into account when you're using Kubernetes. Next time around, I will come with another evaluation factor out of these, and we will touch upon and most likely recap on some of the things as well. In a way, they are all interlinked, like we touched upon the pod disruption budget, and now with the topology constraints, there were some similarities. Again, both of them are there to enhance the availability, and we will look into more of the evaluation factors on the upcoming videos. And that's my time. Thank you.